Hey AP Pre-Calc, this is Ms. Henry, and today we're going to look at section 2.4, all about exponential function manipulation. Our learning target is I can rewrite exponential expressions in equivalent forms. So the exponent properties we learned in Algebra 1 can also be used to manipulate or rearrange exponential functions into other equivalent forms. And the main three properties or exponent rules we're going to use are the product property, power property, and negative exponent property. So as a reminder, if you are multiplying the bases of your exponent, then the exponents are being added. So multiply bases. Means we add exponents. And then for the power property, when we have an exponent raised to another exponent, we multiply our exponents. And then whenever we have a negative exponent, in order to make it positive, we have to flip the base to the other side of the fraction. And then also with our product property, if we have a quotient property, if we are dividing bases, then we would subtract our exponents. So now let's look at a couple of examples. We are determining the horizontal transformations of each of the following exponential functions. So we want to look at what is happening horizontally. So looking at example A, we can see that in our exponent we have x plus 2, and we know that x is b-lion. So this means that our function was shifted left 2. Our original function would have been y equals 4 to the x, and as we said, that has been shifted to the left 2 units. Then g of x, we have 2 raised to the 3x power. So normally when we see 3 times a number, we think it is being stretched, but we know, once again, x is b-lying, so this is being horizontally compressed by a factor of 1/3. And our original function would have just been y equals 2 to the x power. Then for C, we have h of x equals 9 to the x divided by 2. So once again, we would normally think it is compressed, but since it's with x, it is the opposite, so it is being stretched by a factor of 2. Our original function would have been 9 to the x power. And then last but not least, example D, I want you guys to see if you can figure out the horizontal transformation that is occurring. Then if we look back to example 1a, we can use our exponent properties to rearrange function f of x into an equivalent form. Using the product property in reverse, so going from addition of our exponents to multiplying the bases, we go from 4 to the x plus 2 to 4 to the x times 4 to the second power. And then we can simplify that 4 squared to give us 16, and then 4 to the x just remains. So that means that f of x equals 4 to the x plus 2 is equivalent or the same as f of x equals 16 times 4 to the x power. So if you notice, there is no longer a horizontal translation, but now we have a vertical dilation by a factor of 16. So the important thing you want to notice here is that horizontal translations become vertical dilations when you rewrite that exponential function. So they are equivalent. So that's also the important idea noticed here. Remember, your translation is just your shift, horizontal meaning shift left or right. So if we rewrite our function, that left or right shift can become a vertical dilation. So for example 2, each of the following has a horizontal translation. We are going to write the equivalent representation that has a vertical dilation and no horizontal translation. So remember, this first part, we have 2 raised to the x plus 3 power. So remember, when we are adding our exponents, that changes over to multiplying the bases. So this becomes f of x equals 2 to the x power times 2 to the third power. And then we can simplify that 2 to the third power so that we get f of x equals 8 times 2 to the x power. And now we can see that our translation left 3 is equivalent to a vertical dilation of 8. Then example B, here we are subtracting our exponents. So when we are subtracting, that means we are dividing our bases. So that means g of x becomes 3 to the x power divided by 3 squared. So your first exponent goes in your numerator, second exponent goes in your denominator. And then once again, we want to simplify any base that has a exponent of a number. So we get g of x equals 3 to the x power divided by 9. And then I want you guys to try rewriting part C. So next up, we can also use the power property to show that every horizontal dilation of an exponential function is equivalent to changing the base of our exponential function. So what that is saying is our horizontal dilation is equivalent to a base change by a scale factor. So let's look at an example of this. So with this first example, we have y equals 9 to the 2x. Now remember, when we are multiplying, when we have exponents that are being multiplied, like 2 times x, that was originally an exponent raised to another exponent. So that would be equivalent to 9 squared to the x power. And then we can simplify our 9 squared to get answer choice D of 81 to the x power. Then example 4, we're actually going to go in the reverse order to think about which of the following functions is equivalent to y equals 9 times 4 to the x. So if you look at all of our answer choices, we can see that all of them have 16 with the exponent instead of the 4. So we want to think about how we can convert 4 to 16. And remember, 4 would be the square root of 16. So that means 4 is equivalent to 16 to the 1/2 power. And because we are only changing the base of our exponent, the 9 that is in front will not change. So that eliminates A and B and leaves us with answer choices C and D. And then as we said, 4 becomes 16 to the 1/2 power. And then because we have an x, we just put an x there and we get answer choice C, or 9 times 16 to the x over 2 power. So one thing from Algebra 1 that might be helpful is remembering the relationship between your exponent rules and your order of operations. So our order of operations is GEMDAS. And these are referring to what is happening to the base of the exponents. So remember, G stands for grouping, which we haven't really looked at. E stands for exponent. And when you have an exponent raised to another exponent, you drop down an operation and you multiply your exponents. So for example, if I have x squared raised to the 5th power, that would become x to the 2 times 5, which gives me x to the 10th power. So that's when you have an exponent raised to another exponent. Then if you have bases that are being multiplied, then you drop down an operation and add your exponents. And that's only when you are multiplying the same base. So for example, if we have x squared times x to the fifth, because our bases are being multiplied, that's going to become x to the 2 plus 5, which is x to the 7th power. Then, if our bases are being divided, then once again we drop down an operation and we will subtract our exponents. So for example, if we have x squared divided by x to the fifth, that becomes x to the 2 minus 5, which would be x to the negative third power. And then remember, we do not want negative exponents, so in order to make them negative, you flip it to the other side of the fraction to get that to be a positive exponent. So that is a recap of all of your exponent rules, and then we'll look at in class how to do more exponential function manipulation.